theorem that we are going to prove today is that for the arbitrary objects x, y, a, b, we have that the pair x, y is equal to the pair a, b if and only if x is equal to a and y is equal to b. Okay, so let's start with our proof. Alright, so we're going to consider two cases to prove this equivalence. Alright, first off, the pair xy being equal to the pair ab is the same as saying, means the following. It means xy, I can curly brackets, but anyway. Okay, so this means this equality of set. So it's the set xy and the set y is equal to the set ab and the set b. Alright, so first we're going to consider the first case. Okay, so with this equality we're going to consider where x is not equal to y. So not x, so false that x is equal to y. Okay, so now if x is not equal to y, then that would mean that this set over here would have to contain two elements. X not being equal to y means that the set x, y contains two elements, which means that by this equality, the set x, y can only be equal to the set ab, because the set ab on this side of the equation is the only set that could potentially contain two elements. Therefore, forcing the set b to be equal to the set y, and thus forcing b to be equal to y. Now, if b is equal to y, then by the equality of these two sets, and the fact that b is equal to y, that means that x has to be equal to a. Okay? Right, so that's our first case. Our second case is now if x is equal to y. So now if x is equal to y, then that means that the set xy contains only one element. Okay. So if the set xy only contains one element, we are able to say that the set xy is equal to the set y. Because if x is equal to y, then this is just y, which is just one element anyway. Okay. And thus, by our initial equation, the set AB must also be equal to the set B, because we've concluded this about the first part of the equation. And therefore, in other words, okay, so by the equation and by this means that AB must be equal to the set B, and thus A must be equal to B. Okay. Now, if A is equal to B, then by the equation this forces that either x is equal to A or y can be equal to A. It doesn't make a difference. But the point is that x is equal to A and y is equal to B. Yes, right? Okay. Right, finally now we need to prove, so this, what I've just done here has just proved the one way, now we need to prove the other way. And in order to prove the other way, let's just erase all this. Okay, so now we need to prove that x is equal to A and y is equal to B by z. X, y is equal to AB. Okay, alright, sorry. So if x is equal to A and y is equal to B, then we can conclude that the set xy is equal to the set AB, and that the set y is equal to the set by that earlier equation that I gave. Okay? Thus, this. So, because of this and this, we are able to say that the set of the sets are therefore equal to each other, and therefore the pairs are also equal to each other. Right? Therefore, xy is also equal to AB. I have been in love with mathematics since I was in grade 5. I remember it was my grade 5 teacher who inspired me and made me work very hard at the subject, and we all know that maths requires a lot of dedication and a lot of hard work. And sort of ever since then I've had this strong fascination with it, and I would love to be able to take my studies further in mathematics, but yeah, just time won't really allow it at the moment. For me to say to you, maths really is amazing. The way maths, you can take absolutely nothing and you can build something of it. And the thinking behind it and just what it does. I don't know how to explain it. Maths is fascinating in the way that you really only need to know like a couple of principles, and you're able to use all of these principles and develop all of these new ideas and these new theories and bring it all together. And it's a very beautiful language. I really do think it is. I love it.